Welcome everyone in my YouTube channel Educator Jeevan, and in today's video I'm going to talk about the mineral complexes. So in today's video I'll be talking about the oxidation state, number of electrons in d orbitals, and the electron count, or simply the 18 electron count. So for this I want to take one example. Cobalt, tetramethyl, tetrachloride. You don't need to put bracket here. So now let's start with this example. So first of all, let's find out the oxidation number for cobalt here. So before that, you need to know that the CH3 has a -1 charge, similar to the chlorine, -1. So but there are 3 chloride ion and there is 3 methyl, so in total it's like -3 here and -3 here. So as you can see, the overall charge in this anion is -3. So to get this charge, the cobalt should have a +3 oxidation number. So you'll get the, when you add it, you'll cancel each other, and finally you'll get the value. Like when you go to next side, then it's a +3, so it's a -3, so that's fine. So, or you can calculate in this way also. You can take the oxidation number for cobalt as an X, and you can see for the CH3 it's a -3. Similarly for Cl it's again -3, and in total I have it's -3. So this will get cancelled and X is 3. So the oxidation for cobalt is 3. So when the oxidation of cobalt is 3, now let's find the number of electrons present in the d orbital. So for this you need to go to the periodic table. You need to count from here, like 1, 2, 3, 4, 5, 6, 7, 8, and 9. So cobalt has 9 electrons in the orbital. So but when the oxidation number is +3, then the electrons, you need to subtract it by -3. So when you subtract it, 9 minus 3, you'll get the 6. So number of electrons in cobalt is d6 here. So after this, let's start for counting the electrons. So, and we generally do by the two different method. We call it as a covalent method, and next one is ionic. So in the covalent method, we considered like zero oxidation for all the metals. So in case of cobalt, you already know that when the oxidation is 0, it has a 9 electrons. So 9 electron. CH3, there are 3, so they gives 3 electrons. Similarly for chlorine, it's like 3 electrons. And in total, you can see the charge. You can see the charge over there, and that's 3 electrons in total charge. So now you can add it. If you add it, what happens? It's an 18 electron complex. So let's do with an ionic method as well. Here you need to consider the oxidation number of cobalt. Sorry. Cobalt 3, that means total electrons 6 here. C methyl, so you need to include the charge, so it will give the 6 electron again. Chloride here, in case this is 6 electron. When you add the total, it will be 18 electrons. So when you get the metal complex with an 18 electrons, the method you can go for any you like. Either you can go for covalent, or you can even go for the ionic method. It's your choice. But if you get the 18 electrons, then this means this metal anion is a stable one. So if you get the electron greater than 18 electrons, like let's say the 19 electrons, then at the time it is considered as a reducing agent. And if you get the less than 18, like let's say 17, it can be a good, or you can call it as a reducing agent. So let's try with the next example. So hecta H5 cyclopentadiene with the cobalt again. So here the charge for this is a -1, so there are two, there's a -2. So for the cobalt, since this is a compound, no charge in total, so to get the 0 you need to have +2 in cobalt, so oxidation state of cobalt is 2 here. Or you can do in the next method that I have given an idea here, like X for cobalt, and for this it's a -1, so there are two, -1 here, -2 equals to 0, since it is not an cation or not an anion, so you need to have a 0 if it is a complex or it is a compound, so you'll get the value 2 again here. So when the oxidation, so now you need to go to the cobalt periodic table again and see the when you need to get D9, we know that it has a D9 in when it is a 0 oxidation state, but now we need 2, you need to -2, and you'll get it as a D7. D7 is the number of electrons in the cobalt here in this example. So now let's count for the electrons count. So let's go for the covalent and ionic. Again, in covalent you need to consider the 0 oxidation state, so in that case there are 9 electrons, and cyclopentadiene will contribute 5 electrons. You can see in the hapticity over here 5, so there are 2 of them, so they will contribute 5 to the 10 electron, and in total it's a 19 electron. Similarly, you can go with the cobalt. In case of the cobalt 2, the number of electrons will be 7 electron, and since you need to consider the charge as well here, so it's not now it's 5, it's now 5, it's a 6. So when you multiply by 2, 6 2s are 12 electrons in total, and you'll have again 19 electrons in total. So as you considered in the previous example, we got 18 electrons. Now we're getting the 19 electrons. So this is a stable anion, whereas this compound is supposed to be the reducing agent. So let's go for one more example. CH3 IRCO phosphate tritylphosphane Cl and Br. So here we have so many ligands, so different ligands are here, 1 2 3 4 5 6, so it's an octahedral complex. And let's go for the charge. This is a -1, and this is a carbonyl, so 0. Phosphine, again the charge is 0. Here -1, again here bromine, and the chlorine -1. So for this, the iridium must have like minus minus minus, so it should have like +3, so oxidation state. Or simply you can do in this way, let's say X for this, for methyl -1, 0, like for this 0, this one is also 0. For chlorine this is a -1 again, and bromine -1 equals to 0. So if you solve it, you'll get the value 3 again. So oxidation state will be 3 here. So let's go for the periodic table and get into the iridium. Where is iridium? Here you can see the iridium here, so let's count from here: 2 3 4 5 6 7 8 9. So again, iridium has like D9 in 0 oxidation state, but now it's in 3 oxidation state. It means the number of electrons present is there, D9 - 3, that's your 6. So now let's count the number of electrons. Let's use the covalent and ionic method both. So For iridium, you need to have a zero oxidation in covalent, so 9 electron in total. As you know that when it's a zero, it contributes the 9 electrons. So for CH3, 1 electron, cobalt, 2 electron. Again for first triethyl, it's again the 2 electron. They can just, the phosphorus can share a pair of electrons, you know that. And next thing is a chlorine, 1, and again the bromine, that's again the 1. So when you add it in total, 9, 10, 11, 12, 13, 14, 15, 16 electron in total, you'll get the 16 in total, right? Just check it again. Iridium, it's a 9 electron. CH3, 1 electron, so 9, 1, 10. And cobalt, okay, sorry, I did one mistake here. Since we have like the 2 of them here, you can see here there's a 2, so I need to multiply. There is 2 here, so there should be the 4 electron here. Sorry for my mistake. And if you now add it, it's an 18 electron complex. So let's go for the ionic one again. Once again, if you consider the ionic, you need to consider the charge and the oxidation number. So 3 means like 6 electrons. For CH3, you need to have 2 electrons because now we're considering the charge as well. Cobalt is a neutral one, so no need to worry for this. No need to worry, it's a neutral one again. So chlorine minus 2 electron, bromine minus 2 electron. If it added 6, 8, 10, 14, 16, 18 electrons. So this is how you can calculate the 18 electrons. Like this is how you go on counting the electrons in metal complexes, and this is how you get the oxidation number and the number of d electrons present in the metal complexes. So if you have any questions regarding this, then don't forget to write in the comment section below, and see you in the next video. Bye bye.